Have you ever wondered if we could be frozen and return safely with our memories and bodies undamaged? Did you ever wonder if you would be stuck on a waitlist for an organ donation? Did you ever wonder how you could survive climate change? Well, I may have a solution. Climate change is going to make something called the polar vortex go haywire. The polar vortex is a counterclockwise flow of air that keeps the colder air close to the poles. But climate change is causing the polar vortex to weaken and migrate over the North American and Eurasian continents, making some of the coldest winter weather we've ever seen in history. The weather we are experiencing across much of the northern hemisphere is due to exactly this phenomenon happening right now. Humans do not have time to adapt to these sudden freezes, unless they get a little help from our friends in nature, the wood frog and the winter flounder. My biomimicry design will use their molecular adaptation from two organisms. Wood frogs are found in the United States throughout the forests of Alaska and the Northeast. They are the only frogs that live north of the Arctic Circle, and when winter gets cold, they have a special adaptation in which they freeze themselves without fatal tissue damage. Then they thaw out. But how do they return unharmed? Winter flounder live in the bottom of the coldest waters in the Arctic. Their environment is surrounded by ice crystals. How do they stop from becoming fishsicles? These two animals share one thing in common: ice nucleators. Ice-binding proteins made from a specific line of DNA that is generated through mRNA, messenger ribonucleic acid, building blocks of our cells. Ice nucleators bind to any ice crystals in the bloodstream and prevent it from growing any larger. What this means is that ice crystals will not be able to cause cells to be ripped apart from the inside, which is what happens when you start to freeze. Ice crystallization causes massive cell damage and ultimately death, but ice nucleators basically lower the frog and fish's freezing points. This means they are almost impossible to freeze. If we can adapt this molecular adaptation into human blood cells, then freezing will no longer cause frostbite or death. Now, with our main objective in perspective, how might we do this? We can outline the possible solution by answering 3 questions. 1. How might we increase cold resilience? As stated earlier, the wood frog and the winter flounder use a similar technique in survivability of these temperatures: ice nucleoids. 2. How might we extract ice nucleoids? This is already done for ice cream, except by acquiring one of these animals and taking their ice nucleators and biochemically engineering it to work with ice cream. 3. How might we make this suitable for humans? Much like the COVID-19 vaccine, we can introduce a strain of DNA into our bloodstream for our messenger RNA to read and produce, and from there, the ice nucleoids can get to work. It's possible that this change in our DNA could be passed down from generation to generation. In other words, we humans could evolve to survive freezing cold in a matter of decades. Another issue that could arise is the possibility of the winter flounder and wood frog going extinct from the demand for their DNA. While that does sound threatening, recently, CRISPR can be used to copy and fabricate the same strand of DNA to make the ice nucleoids so they could live in their habitats undisturbed. Benefits and the future. Cryostasis, or the state of being frozen alive, is a huge leap in technology, and the possibilities and doors that would open would be era-changing. A good example of cryostasis is from the Marvel Cinematic Universe, which already imagined this possibility with Captain America, and especially the Winter Soldier. If you ever wondered what it would be like to go in and out, what they call cryostasis, or being frozen, Bucky is constantly going in and out with no side effects, whilst also staying the same age. This is also a good transition into what cryostasis could bring to interstellar travel. We're going to need this for traveling outside our own solar system, since it takes years to just travel to Jupiter. Without cryostasis, imagine being stuck on a ship for 2 years. A good example of this is from the movie Passengers, in which a few hundred people on a ship traveled to another Earth-like planet to colonize it. Aside from cryostasis, humans vaccinated with ice nucleating RNA will be immune to hypothermia and extreme temperatures. Although there is a freezing point, it would have to be incredibly cold to freeze or cause harm. So you will survive it all. It will be a huge step in human evolution. Call it a cryo revolution.